You just have a device that is not just on and off. It's something that is clever, intelligent.
That you can get into any company and program deep learning.
The build-up to what's happening or going to happen with AI becoming pervasive and accessible. Welcome everyone to the Voice of Innovation Fireside Chat. My name is Bram Gene. I'm the CEO of Revolver, and we are hosting these conversations together with Syntiant. The goal is to explore the work of innovators and the future of pervasive AI. And today, two great guests. First of all, of course, Busch, the CEO of Syntiant, and Fabio Violante, the CEO of Arduino. And Arduino is the open source hardware and software platform for creating interactive electronic objects. And in the light of things that are pervasive, Arduino certainly is pervasive. I want to hand over the conversation to Kurt and Fabio. And first of all, ask Kurt to frame this conversation in terms of what's happening in AI and specifically why it's relevant for you to be talking with Fabio about this topic. So Kurt, over to you.
Thank you, Bram. My name is Kurt Busch. I'm the CEO and co-founder of Syntiant, and we are building a new type of processor to make machine learning, specifically deep learning, pervasive. Today microcontrollers are in everything from computers to greeting cards, and our thought is that the machine learning really can be that type of technology, that you shouldn't have to go to the cloud to get the benefits of machine learning. And I thought, who could it be better than to talk with Arduino that has really brought microcontrollers to everyone? If you look at where your first experience with technology is, more often than not that it's an Arduino controller. And our thought is that, we want to make machine learning the same type of accessible technology that Arduino has brought to the market.
Hello, Bram. Hello, Kurt. Thank you very much for the invite today. It's really exciting to be here. My name is Fabio Violante. I'm the CEO of Arduino, as you said. And, it's a very interesting period of time. And, we see more technology available, and we are happy to be, bringing to people the usual message that we do have in Arduino. So that is enabling people to innovate by making complex technology simple to use. And that's the mantra of our company. And I think it was what Kurt was mentioning. It's really, really spot on what we're doing.
Because Kurt, you in previous conversations referred to what happened in microcontrollers as sort of the analogy or the build-up to what's happening or going to happen with AI becoming pervasive and accessible. Can you maybe elaborate on that? And indeed, Arduino is sort of the, I guess, poster child of that movement, right?
Sure. I think that, when we often think about AI today, we think about NVIDIA GPUs operating in the cloud, burning, hundreds, if not thousands of watts, doing heavy AI training and inference. But to really benefit from AI, you can make it pervasive. You can have it in everything, whether, today there's a little bit of AI in your cell phones, but, beyond that, once you get smaller than cell phones, there's really not very much in the device, and everything has to go back to the cloud. And that introduces things like latency, and it's not nearly as secure as if it's in the device. It draws a lot of power, it decreases battery life, all those types of things. Then, our thought is that if we built a processor that was effectively a new type of, let's call it MCU class device, something that draws, under a milliwatt and can bring a tremendous amount of deep learning processing, then that deep learning could become something that everyone could use. And our thought is that deep learning is extremely good at interfacing the real world to machines. And we think moving forward, things like voice and image and gesture, various different kind of sensors that interact with the real world can really benefit from AI is about bridging the two of them. I mean, we're talking now, it's our most efficient way of two-way communication. And using deep learning, we can start using voice as a way of interfacing to devices. And if I look at what type of devices are most pervasive for engineers, where do you start with? You often start with Arduino boards. And our thought is that, where Arduino is today, we can make AI something in the future, the very near future.
Yeah, interesting. What are your thoughts on that, Fabio?
No, I think I totally agree, because if you look at the evolution of our space, that was mainly based on simple microcontroller, very robust microcontrollers in the past. Of course, the market has evolved. Now we do have the capabilities to do more stuff. We have more powerful microcontrollers that enable a different set of applications and a different set of problems to be solved. And it's also important to note that there is a ton of new sensors available. This means that possibilities now are countless. So with all the MEMS that you have, from fantastic pressure sensors, you have accelerometers, you have time of flight sensors, and so on and so forth. So if you combine this with the power of this next generation of ultra low power microcontroller and ultra low power neural networks, like in the case of Syntiant, where you basically can have battery powered devices spread across your home, or spread in your garden or in your factory, everywhere, that can do things that are not just binary operations like on and off, but they can be sort of augmenting you as an individual. So augmenting the possibility that you can do. That's really incredible. It's a new era. It's totally a new era where you can just use this technology in a simple manner without having to go all the time through a very fast network to the cloud, to the processing, or through 5G, and sensitive to your input, and it can react in the right way.
No, Fabio, when when I started in electrical engineering, it was relatively inaccessible. You go out and you buy a breadboard, and you buy some LS parts and things like that, and try to connect them, and maybe get a basic circuit board and whatnot. But when I wanted to teach my kids about it, I went out and I bought an Arduino board, and everything was kind of right out of the box. Within 10 minutes or so, we had it actually doing something. Could you give us kind of the background of Arduino and how this really came about? Because I think it's enabling a lot of people today, and often that first starts. So I'd like to see how it started.
Oh, it's a funny story. And, I've been appointed CEO of Arduino in 2017. But I think I can say that I am the grandfather of Arduino. Because one day back in, I think it was 2000, more or less, I went to a place here in the northern western part of Italy, in Ivrea. That was a glorious place, because for those that are more or less of our age, there was a company called Olivetti that was making personal computers and competing with IBM. It was quite successful. So unfortunately, that company was not really successful in the era of compatible computers. Long story short, in the building of Olivetti, a new design school was born called Interaction Design Institute of Ivrea, that is the city north of Torino. And I was visiting that school that was trying to combine design and engineering and computer science, so teaching physical computing to students, to mainly to designers, so to people without a solid background in computer science. And so it was a pretty unique experiment. And I was visiting that school during my PhD program, and they were asking me if I want to teach electronics to their students. Unfortunately, I was not the best electronic engineer in the world, so I just said I'm not the right person, but I know the right person. And I asked my friend Massimo Banzi, that is one of the co-founders of Arduino, if he wanted to teach electronics to those designers. And he was interviewed by a bunch of important people, and he was hired. So he started doing these projects with designers that had very little background in computer science, trying to combine, programming, electronics, and design. And after, probably 100 projects, he realized that many projects shared some aspect in common. So they were basically the same things, like a circuit, with a little bit of microcontroller instructions written in C code, etc. So they came up with this idea of building a product that could help, speed up the process of standardizing the way the students were making their projects. And they came up with this idea of the Arduino, let's say the prototype, the first Arduino Uno. And also the clever thing was that Massimo was able to aggregate a number of people, namely, the co-founders of Arduino, David Quartielles, that brought in the idea of making everything open source, including the hardware. Tomaigo, that now is a professor at the University of New York, a center called ITP, basically one of the biggest experts in the world in physical computing, one of the pioneers. And David Mellis that wrote the IDE, because the software part, we don't have to forget the software is more important than hardware today. So he came up with the IDE and the language, etc. So I think this team was really amazing. And they created this idea just to solve an everyday problem of them as teachers. So how do I help people, designers that with zero background in technology, to develop code? So long story short, that's the way Arduino was born.
There's been all kinds of great projects with Arduino over the years. Perhaps you can share with the audience about what would have been your favorite projects that you've seen done with the Arduino chips and boards and software.
Yeah, I think that Arduino had a crazy evolution, because from the time they started with a few students, a lot of teachers were spreading the Arduino way of doing stuff across the globe. And I think some of the projects that really impressed me that were stemming from the Arduino developments were, first of all, the 3D printers. Because the market of 3D printers was a market mainly made of patents. So there were like huge conglomerates, large companies making very niche projects of very expensive 3D printers. The moment a microcontroller with a bunch of input outputs was available, we're talking about, very simple, very simple microcontrollers, but enough to manage and position motors in the right way. So the moment Arduino, mainly Arduino Mega, that's the board that was used, is a little bit bigger than the famous Arduino Uno, was on the market, people started using it to build their own 3D printers and extruders, etc. So basically a new industry was born of open source 3D printers revolving around the Arduino Mega. And another thing that was impressive is the drone market, because there was like a military drone industry, etc., but nobody was thinking about making open source drones. So Chris Anderson from the Wired magazine, you may know him. He's a person that shaped probably part of our existence, part of our world. He built an infrastructure for building drones, open source drones based on Arduino. So those are two examples of the transformational power of Arduino, but we have countless things, from intelligence hair dryers to fish feeders to incredible application in agriculture, in industrial fields, etc.
Yes, speaking of industrial fields, how do you see the progression or the evolution of Arduino as a hobbyist or an early experiment platform to more of a professional or industrial type platform?
Absolutely. So it's something that I'm pushing quite a bit the company to towards this dimension, because what I did, one of the things I did when I started at Arduino was to sort of identify the market that we were serving, and we're talking about mainly three major markets. One is the education, where Arduino has been always popular, and we did gave a spin towards like more the curricular activities for Arduino to help teachers more than students as well. There was the makers and hobbyist market, and there was an industrial market that was quite interesting, because Arduino was already a ultra popular platform for prototyping. Huge companies from Coca-Cola to Audi, Apple, you go to LinkedIn, they look for Arduino professional on LinkedIn every day. And it's pretty sure that they use Arduino. We interviewed a bunch of them. So we realized that Arduino was a fantastic rapid prototyping tool for them. But there was also a bunch of companies that were using Arduino as a tool in production, because they wanted, for different reasons. On one side, because they wanted the simplicity of the platform. They were not willing to co-op with a complex programming infrastructure and third-party system integrators, etc. On the other side, the hardware is very robust. So every Arduino, even the Uno, even the cheaper one, like the Nano Every, that is a $8 board. We're talking about peanuts in the industrial world. Those products are tested one by one. It's like it's like a high, super top quality iPhone style kind of testing applied to an $8 thing that is manufactured in quantity. So. And of course, there is also this aspect of the software library that is pretty unique, because we do have an ecosystem of thousands and thousands of libraries that allow you to interface with each type of sensors very easily. So it's not only our merit, but it's also something that stems from the community work that revolves around Arduino that makes this platform very, very robust. So we thought about, giving a spin to Arduino towards this professional world by creating products that are natively designed, having in mind, the industrial world. I think the biggest product we do have right now is this one. So it's the Arduino Portenta that you may have seen on the internet, but it is not important. But what is important is the philosophy behind the product. The idea is to provide industrial-grade components, with the proper longevity of the product, with the proper interfacing, with the proper standard and certification that can be interfaced towards, more specialized hardware. Like we can anticipate, probably, we're working in a collaboration also with developing a collaboration also with Syntiant for more sophisticated application where they can be used also in the industrial environments. So we are creating a line of products that are more vertical, more specialized, more robust, specifically thinking about the industrial market. And there is a specific division that has something in common with the rest of the company, but it's tailored towards this type of customers.
You said something earlier about the software being much more important than the hardware today, and it reminds me of when we started Syntiant. We, being in 2017, my co-founders and I would tell our friends we're starting a new chip company, and the our friends would laugh at us. They say, yeah, that's really funny. No one has started a chip company in like 20 years. What you really should be doing is a SaaS company. And it's funny is that software is really where it is. And now I look at Syntiant, and we're about 80 people, and I look at our staff, and I realize we did start a software company. Almost everyone is a software engineer within Syntiant, so it's definitely more than half. And so maybe you could expand a little bit about how you see SaaS interfaces with Arduino, and how that's going to be accelerating your development and whatnot. I think we all sit back and look over our organizations and realize that they are software companies.
No, absolutely. So Arduino, the software stack is very, very important, and it's much more complicated than the normal companies, because having to build tools that make things simple for people to use, to develop code, etc., is an order of magnitude more complex than just solving a problem. But this is the challenge that we face every day. What we realize over time is that there are some advantages also in embracing the SaaS world, in terms of ease of update, in terms of putting the compilation in the cloud of sophisticated pieces of code, so where you have much more powerful stuff, in order to create something that then at the end of the day can be running on a very little piece of microcontroller that does the final job, like in your case. So basically, you do have a ton of capabilities in terms of convolutional neural networks, things that are very sophisticated, and the model can be created in the cloud and pushed to the device. So what we are doing at Arduino in terms of software is, on one side, working on the development environment that we do have and improving the libraries, improving the APIs, improving the bootloaders with secure bootloader features for industrial application. That is very, very important. So there is a team that is working mainly in that area of the embedded engineering, improving what we do have, also putting real-time operating system behind Arduino. We are collaborating with ARM Embed from that point of view. So the newer board from Arduino are equipped with a more sophisticated real-time operating system for low power, for high performance computing, even in the small devices. And that's one thing. On the other side, we do have a group that is working on the cloud side to develop better and better cloud-based tools. So we do have a development environment in the cloud, but we do also have an IoT cloud that can be used, for example, to let device communicate among each other, to create nice dashboard, nice application, with the aim at some point later this year or early next year to get to a point where we develop a marketplace where some specific application can be purchased by their people like you. I don't know, you create a vertical application based on the Syntiant hardware, but it's mainly a software stuff that can be purchased from the marketplace that we will be releasing. So that's the dream situation. So far, we allow people to develop code and to let device communicate among each other or with humans through the dashboard. So it's something that you can go and check out on our website. It's something that is existing and tested by millions of users. So it's a huge investment, but I think it's important at this point.
Speaking of that cloud interface, what are your thoughts about the different radio technologies, the things like Wi-Fi and Bluetooth, and for the LAN or narrowband IoT or LoRa, things like that for wide areas? I think people like to get to understand what's the Arduino view of using these different technologies, and what do you plan on including in your boards?
Absolutely. So we today the quantity of radio technology and communication technology that is available is really incredible, because you can go from ultra high-speed Wi-Fi devices to high-speed Ethernet Wi-Fi, field bus things, but also you can get long-range, low-power radio from narrowband IoT, Cat-M1 LTE, Cat-M1, LoRa, Sigfox. So at Arduino, we try to be quite agnostic. So right now, we do have a series of boards called the MKR that support almost all the type of telecommunication. So you can decide the microcontrollers is always the same, and we use a separate modem for the different types of telecommunication. Of course, when it comes to real-life applications, it's not like working in isolation, like being in a lab or in my house where I can have like ultra availability of ultra fast networks, gigabit networks, etc., and then power connected devices. In many cases, in industrial application, but even hobbyist application, you have a garage, you don't want to couple with batteries. You have an application, for example, where you want to measure something that is behind a manhole, so it's very complicated to get the radio signal out of this crazy situation that can happen in your home, it can happen in a factory, that can happen on a road, in a smart city, etc. So different types of technologies are now available. Some of them probably are interesting for some aspect, like LoRa, for example, because of the possibility to create very ultra low power networks that are also long range. So this means that with a few access points, with a few gateways, you can get all your devices controlled. So what we are doing at Arduino is creating microcontroller boards that have ultra low power per se on the microcontroller side, but also using all these different types of modem and technology, and making them available as a combination or just in the same board with all the products. So it's a very important endeavor, but we are collaborating with a bunch of companies, and we do have quite an expertise on those devices at this point.
So on your new boards, how do you see AI being deployed, and what kind of applications do you think they're going to be the first, second, third sort of applications to use deep learning in the Arduino ecosystem?
Yeah, so the temptation is always that's a great question, because the temptation at the very beginning is to think about the normal use cases. We are now using Alexa, and everyone is getting addicted to Siri, Alexa, this kind of assistants that have a lot of intelligence and a lot of capabilities when it comes to the artificial intelligence. People don't realize how complex it is to not the device per se, but what happens in the cloud. What I think is important is that we are now at a point where we can bring this, at least part of these capabilities, to a tiny battery powered device, and that's really impressive in terms of what you can do. Because voice can be used also in factories. It can be used in an environment where, a noisy environment, where you can basically, instead of touching something, you can use voice. But there is a bunch of applications where you can use other types of sensors that are tied to a sophisticated neural networks, like the ones you deploy on Syntiant, and those applications are the ones that, the funnier one, and the most interesting from the research point of view moving forward, that can become products in the future, like making an intelligent knife. Massimo did a course, Massimo Bazzi did a course at one of the design institute in Europe, the Copenhagen Design Institute. So that course was focusing on interesting, innovative ways of using artificial intelligence, and one of the students created a knife that was equipped with the ability to learn how to correctly be used and then correct the final users when he was improperly using the knife. So a big chef was training the knife the first time, and then you were buying this intelligent knife and use it to learn how properly cut your onions or whatever, I don't know. So that's a crazy, very simple, stupid, let's say, example of the possibilities. We can add intelligence with these kind of devices, with our microcontroller, with your chips, on relatively simple boards, because we're talking about miniaturized technology, so they are simple theoretically, but when building the board, you need a little bit of capabilities. But you can create a ton of different applications that can be extremely important for simplifying our life.
Yeah, I'd love to see that intelligent knife. Is it available? Are there demos? Maybe we need to post a link to that demo. I often think about these types of intelligent gadgets. When if you're building something and using a power screwdriver or something like that, by the end of the day, you get very good at adjusting the torque and whatnot with the trigger, so you don't strip anything, and you have a kind of a good feel for how things going. But unless you do it every day, you start off in kind of a clumsy situation, right? You strip screws, you break the heads off, things like that. And your knife is kind of analogous to that, is that if you put AI into these everyday devices, that they could sense what's going on, right? So you could sense in a screwdriver, are you about ready to strip the head? Are you are you going to break the head? Are you going to do something like that? Or are you holding the knife incorrectly? These are sort of the things that I really see, that low power pervasive AI will be there, and everything will be a smart device, that you'll just pick up a device, and it will guide you in the proper way of doing it. And it really brings the novice to kind of medium level skill. It's probably not ever going to get to expert level skill, but it could get you to medium level skill, or some degree of proficiency right out of the gates. And I think that's one of the main kind of advantages or promises of this kind of pervasive AI.
I do agree, Kurt. So the point I was trying to make before is that at this point, artificial intelligence and what you're providing in terms of low power uh, allows people to stop thinking about zeros and ones. So here we have the flexibility to think about, devices that basically can adapt to all conditions, that can understand the stuff, that can understand the context where they are placed. So it's really a new era, because not always you are able to have a data center connected to your stuff. So think about drilling a hole somewhere in the countryside. You cannot think about having the 5G, drilling machines or whatever. So if something can avoid breaking, like an expensive drilling machine, just because it's clever and it's smart and it's not just 0-1 mode engine on off, that's very important. And it will be more and more important in opening the windows, opening the shadows, having a little bit of brain everywhere. Even our human body is made with a brain that is sort of distributed, because if you think about the way the human is made, is not only the head, but there is a lot of intelligence in the arms. It's a lot of intelligence in the muscles. So it's quite impressive. So we're now enabling a new generation. So we are just scratching the surface of what is going to be the future, and probably the complexity that we can reach in the future. But it's quite exciting.
So, you allude to all of the things that are coming to the future, and with just in the last 10 years of my career, I've seen things changing so very rapidly. More people are connected. There's more breakthroughs, more compute power, and whatnot. How do you go about keeping track of innovation and making sure that you and your organization are really on the cutting edge?
Yeah, so we are trying to partner with a bunch of people that have advanced research. So we are in a lucky position, because our community is huge. We do have like more than 30 million people visiting our website every year. Millions of people, 39 million people downloading our ID. So we are in a good position to do all this kind of partnership with visionary companies, because they are interested in working with Arduino because of the impact that Arduino can have. So we try to exploit this privileged position to take their latest and greatest technology, train our people, and also make it available to the masses by democratizing it, by carving nice deals in terms of pricing, so that we can put their processors, their technology on a cheap board for people, or we can develop a nice piece of software, a companion piece of software. So the board will be normally priced, but the software is somehow subsidized by the partnerships that we do have. So we're trying to do all these kind of tricks to get to the point where we can put the greatest and latest and greatest technology into the hands of the majority of people that we can. And probably not all the people understand what we are trying to do, but when you get extremely reliable LoRa networks or extremely reliable Wi-Fi with high quality chips, it's not something that we give that is a given. It's something that is the outcome of a precise design that we built in order to democratize those technology. So, and that's the mistake that many people make with Arduino, and say, okay, there is an alternative like a Chinese microcontroller, 8-bit, whatever, Wi-Fi, etc., super powerful. But then when you get to something that needs to be robust, that needs to work in any condition, for example, radio conditions, if you get an original Arduino, probably the likelihood that it works is much higher. And that's the spirit. And we work with their research and development. We work with them to try to understand what we can do on the software side, more than on the hardware side, but also on the hardware side.
Yeah, I often see Arduino in the educational environments, and as I said, it was the first thing that I purchased to teach my kids about electronics. What kind of advice can you give to younger people that are just starting off this adventure in technology, and what have you learned over your career that could really help them accelerate to get to their goals?
Absolutely. So the first bit of advice is that a lot of young people, they think a technology like as a given. So it's the iPhone, it's the the Netflix things, etc., as something that is just you use it, like the water on the tap. So you just open the tap and get the water. Nobody cares about how the water is made. So the first bit of advice is start thinking about that technology. That technology can be changed, can be improved, can be hacked, can be made yours. And with things like the Arduino, but also all the web technologies that are available today, getting to a shift from technology, I call them spectators, to technology actors, it's much simpler. You go on Amazon, buy the Arduino starter kit with a booklet and a bunch of components. You get to understand C programming, uh, you know, some build some projects that are very effective and impressive. So the first thing is this transition from spectators to actors. So teaching them that this is possible, it's very important. The second thing I think that is quite that is quite important is that with the availability of connected technology, they can do interesting projects, and the concept of project is what makes the difference with Arduino, because the usual way, we were joking before just this video about my books, my bookshelf, and we were talking about a book that I have that is this book of Principle of Compiler Design. This is the old way of teaching stuff. So you basically get a book, go through the theory. With Arduino, and for me was a Copernican revolution, is that everything is revolving around the project. So the project is at the center of the activity, and you first do something that is very that provides you instant gratification. You get the things done, the robot moving, etc. And afterwards, you understand what you did, and what did you do to get the robot moving, the robot working, etc. That changes the perception. I make you just an example. I don't know if we do have time, but I think it's important. When we did the first, let's say, curricular project in Spain, thanks to David Cuartiellas and the team that is working in education for Arduino, we did a survey of those people that were doing in parallel in many schools in Barcelona a bank-sponsored project called CTC. So it's Creative Technologies in the Classroom. So we did have a population like the normal population of schools, and the number of female that wanted to do like an engineering school after their high school was very tiny, in the order of magnitude of a few points, like 5%, something like this. So then they entered this program with Arduino in collaboration between the bank, Arduino, and the school, and all the high schools in several cities. One was Barcelona, the other one was Valencia. So the same survey at the end of this CTC program was saying basically that almost all the female students in the school wanted to study scientific matters, like STEM matters. It's like 90%, 70 to 90% depending on the school. So that was from 5% to 70, 90% increase, just based on the showing what they can do by doing a CTC program. So this means project-based learning works, and that's the Arduino philosophy, and is going to stay as the Arduino philosophy forever, for humans, for normal humans, for students, but also for companies. Because project-based means that you show the value of an IoT project to your CEO in 5 minutes, in 1 week, in 2 weeks, in 1 month, instead of having to call one of the big consulting firms, working for 6 months and showing almost nothing at the end of the day, so the project get cancelled. That's the transformational power of Arduino.
I think you two covered a lot of ground. It was super interesting to be following it. There's actually one thing I'm curious about, Fabio, and in a way you touched already upon, like, Arduino has always been sort of like very easy to start with, low entry barriers, right? Very approachable. And I was thinking now, when technology keeps advancing, and for example now AI comes into play, and in a way it becomes more complex, like, how do you keep that approachability and those low barriers whilst you're also expanding the possibilities and the capabilities of the Arduino products?
Yeah, this is a great question. So the point of making more complex technology simple to use is really tough. It's a huge problem. We tried, for example, with FPGA. We do have still a tool in the working to make the FPGA development simple as we promised. It went through 3D redesign of the user interface. It's quite expensive way of doing stuff, so people normally don't understand how expensive it is to make stuff simple. So what we're doing right now is twofold. On one side, we do have a huge design team for our side. So we have a team of about 120 people, of which like 10, 12 designers, UX designers, interaction designers, etc. So it's a huge team compared to the size of the company. And that's one way. The second way is, of course, partnering with companies that do have specific expertise in making stuff a little bit simpler. So, for example, on the AI, we're working with Edge Impulse for partnering on a bunch of tools and experiences and software, etc., for users. So that's the second way. So the partnership is very important. What we're trying to create is like a framework umbrella under the Arduino cloud. Where we can also combine a bunch of tools, so not only our tools. For example, we're partnering with Altium on the design part for design circuit and making all their tools available to our customer base free of charge as viewers or as editors, etc. So we are trying to partner with those people that are leading and also put their material, trying to share, trying to repurpose their material in a way that is like more project based with a huge content effort that we are keeping doing. It's expensive, it's huge work, but I think that's the only way, because complexity is there. So you can try to simplify and oversimplify, but at some point, some concept needs to be need to be taught to people. So we're trying to figure out these kind of things, collaborating with university. For example, we're now collaborating with the Harvard University on a tiny kit for AI. They do have an online course that has been extremely successful. We're collaborating with Coursera and Edge Impulse for another course on AI. Based on our products. So we're trying to do all these kind of initiatives. You know, the sector where Kurt is working, it's a complex sector. So I'm not the expert on the latest and greatest neural network technologies, although I'm informed of them. But we're talking about sophisticated technology. What we're trying to do is work on the applications, on the projects. So moving people from just ignoring those things because they are too complex and moving them into using this technology and then going backwards to understand what's behind the scenes and how they can tweak the technology to make it work differently. So the usual approach. So we get to the end, final outcome, and then from the final outcome we go backwards and teach people the how. And that's the reason why we're developing boards, we're developing code, we're developing examples, and etc.
And Kurt, I was wondering, I'm making the assumption that for you as Syntiant, like the company is of position to get designed in these the biggest smart speakers or other smart devices of the world by these big OEMs that everybody knows, and it's of course a very different ecosystem than the very bottom up world of Arduino. Even though Fabio, of course, alluded that that's also making its way into the big companies. But I'm curious what your thoughts are on how what this ecosystem of Arduino can do for you as Syntiant.
Yeah, I think that's a great question, Bram. So we started off really with a very, I'd say, directed tier one strategy, and it has worked quite well for Syntiant so far. We've shipped tens of millions of units. We're built into things like cell phones and smart speakers and AR VR glasses and remotes and wearables and earbuds and things like that. But our real belief is that AI, or specifically deep learning, is the programming language of the future, and for it to be very pervasive or become a pervasive technology, it needs to be in everybody's hands. And so our view was, let's start with the big guys. Let's ship lots of units. Let's make sure that our company is able to ship, hundreds of millions of units a year, which we're on path to do that, and it's looking quite good. But AI is extremely useful. I mean, once you have data, you can do great things with it, whether the data is for image or whether it's for voice or whether it's for sensors. And there's no reason why everybody shouldn't be able to do it. The chips are small, they're inexpensive. There's the view is that for almost no money and for no power, you can put the power of deep learning into just about any device. And one of the things that we saw is that the number of companies that have skilled AI practitioners is extremely small. If you want to sell into the large companies, the Googles, the Amazons, the Facebooks, the Apples, they have armies of deep learning people that can program production level deep learning. But for deep learning to become very much like programming a microcontroller, is that today in the microcontroller world, you can walk into just about any technology company and there's someone there that can program a microcontroller. We need to get to the point that deep learning is the same, that you can get into any company and program deep learning. And our view in working with Arduino is that why not let's start with education. Let's start with programs. Let's get those 30 million people trying deep learning. It's not really that hard. You just need to get in and do it. But today it is really the domain of the large companies. And for deep learning to be truly pervasive, it's going to have to become the domain of the everyman. And that's really what we want to do with working with Arduino and getting these chips into everyone's hands. So, in a very short period of time, they can, program up download some data, program up a deep learning network, deploy it, see how it works, try it, trial and error, and get these things going and go, maybe there's something to this. I'm going to try this AI thing. Maybe training a network with data is a whole lot easier than trying to figure out what if then else statements to figure out how my machine's going to work.
Yes.
Let's just train it with data. And I want it to do this. I have data to make it do it. Let's just train it, and let's not worry about the logic. And that's where we want to get to. We want to get to that outcome, and that outcome for everyone, not just the domain of the huge companies.
Fabio, Kurt, I want to thank both of you. It's been a great conversation to follow. I've learned a lot. And also want to thank everyone who's watching or listening to this conversation. You can follow Arduino, Syntiant, or Wevolver on any of your favorite social media channels. And if you've enjoyed this conversation, if you've learned from it, please share it with a friend who can benefit from it, and leave any thoughts or questions that you have in the comments. I'm looking forward to the next conversation. Thank you.